So hello, everyone. My name is Rick Spurgeon. I'm a developer advocate here at Kong. I provided some links here for you to reach out to me if you have any questions about the topic today. Today, I want to talk about APIOps, just a little bit in the beginning, and then I want to do something really fun, which is use some AI to build a new API and an APIOps workflow and showcase how APIOps helps you deliver APIs to production. So let's get started by just talking about APIOps first. API first is a methodology for defining API specifications as the source of truth for APIs. Now, what that means is a textual representation or specification of an API defines the behaviors, and it can be used to generate documentation, code libraries for clients and servers, and really provides a great documentation source of truth for your API. At runtime, API gateways provide a key abstraction for APIs behaviors. So things like security, traffic control, things like that are critical from an API gateway. It prevents us from having to write that functionality into API service code on the back end. So how do we bridge these two topics? With Kong, we can use a declarative tool called DEC to bridge these technologies. The way you would do that is you might have your API specification, typically for REST APIs in the form of an open API specification. You can use DEC to generate from that specification an API gateway or Kong gateway declarative configuration. That configuration then can be synchronized or applied to a Kong gateway to enact those behaviors onto a gateway. So this is all nice and simple, but as teams have grown to adopt microservices and domain-driven design, APIOps has needed to grow with it. It's gotten more complicated. So practical APIOps requires more complex behaviors to enable what we like to call federated APIOps. You want to empower development teams to be able to build and deliver their APIs, and you want to give them the ability to self-service, to control their own destiny in their API delivery. While at the same time, as like a platform team might need to still enable governance capabilities. And we want to do these two things together. So federated means enabling these teams to do as much of this as they can on their own, while enabling a centralized team to maintain this like centralized control and potentially own and deliver the APIs to the actual infrastructure. So we can do this also with Kong using our Kong declarative tool DEC. DEC provides beyond the generation capabilities, things like transformations, merging, verification or linting, and then of course, the ability to deliver it to the production or running runtime Kong gateway. And we can build these capabilities into pipelines or workflows that match what you typically see in CI/CD systems. So for instance, GitHub Actions allows you to declare workflows. You can imagine these pipelines here match those really well. The teams could have different repositories, and the code and the declarative configurations could be sourced and copied across them. And as we're going to see here today, we can use common development workflows like PRs, reviews, and automated systems to deliver these things using very well-known GitOps style approaches, right? So I want to get started because I have a long demo here. I want to try to get to it. So let's get started with a coding demo. The fun thing we're going to do today is we're going to use AI to help us deliver some of this. And we're just going to start from the very beginning. I have a totally empty repository coding folder here. And what I've done is I've found a really fun tool called ChatBlade. And ChatBlade allows you to interact with the ChatGPT API directly on the command line. Here I've aliased that to the term HAL, so that the command HAL, so that I can just make this fun, interactive, and quick to type. You can see that I just aliased that and use my credentials to run it. So what we can do is ChatBlade command allows us to interact with it directly using something akin to like the web browser you might use with ChatGPT. So we could say something like, ask it, what is an API gateway? And we stream back a response from ChatGPT just like you would on a web browser. But what I really love about ChatBlade is it can interact using common Linux principles, using standard in, standard out. So we can say pipe a question to it. So briefly describe APIOps, and I'm passing that directly into the ChatBlade command. And it will, again, stream back a response for us. We're going to use this to build code. Now, how can we do that? So the way I've started to use this is I ask it a very specific question. Write me a bash script that initializes this folder to do a Node.js project. You'll see that I pass that through the ChatBlade command and then again through the T command. That will allows me to pipe it out to a file, but also vet what we get back from ChatGPT. You would, of course, wouldn't want to run anything that you haven't first vetted from the AI system. So here, it's going to build a script for us to run. And you can see here, it's a bash script. It'll initialize a Git repository. It's setting up a package.json file, and it's setting up a git ignore, installing dependencies, et cetera, et cetera. So I vetted that quickly. I've ran it a few times. We can go ahead and do this, and it will run this for us. We now have a functioning Node.js repository here locally, just by asking ChatGPT a question. API first, as I said at the beginning, is really important. We want to specify APIs using a specification. So I'm going to ask ChatGPT to write us an OpenAPI spec file. I want to call attention to this little -L flag that I'm passing to the ChatBlade command here. That means use the last session for ChatGPT. It basically says to ChatGPT, continue the conversation. This will allow me to ask questions in sequence and continue on a conversation with the AI technology as I go. I don't have to rephrase or reprompt every time. With -L, it's just using the previous context for the conversation. So here I'm asking it to write an OpenAPI spec for a very simple API, just like a Hello World API. And we're going to tee that off and look at it, and also to an OpenAPI spec YAML file. So you can see what that looks like there. Great. Now I want to implement it. So how would I implement it? ChatGPT, please write us a JavaScript web service that implements the previous OpenAPI spec. That's going back to that context of the conversation. ChatGPT can just read back the OpenAPI spec that it previously generated and create a very simple Node.js application for us here. So that's now in the server.js file. We have an OpenAPI spec file there too as well. How would we run that? Well, everyone loves Docker. We use Docker, so let's go ahead and do that. Build a Docker file for the JavaScript service. Again, the context allows us to ask very simple questions. Great, it's created a Docker file for us. And we can then ask ChatGPT, let's go ahead and create a script that will build the image and run it. I'm also going to ask ChatGPT to run the Docker container on a specific network. That will allow us to bridge it later to the API gateway that we're going to deploy. So here we've asked it to create us a little script. It will build the container, create a network, and then run. I think that might be a little bit of a problem if the container already exists. So let's go ahead and do that. So let's go ahead and run it and see if that works for us. Okay, so we have a Hello World service running. Can we ask it a question? Yeah, hello world. So our service is running here on Docker and we're up and going. So now we want to put an API gateway in front of it and start to build out APIOps. So how will we do that? Today I'm going to show you Kong Connect. Kong Connect is Kong's SaaS product that provides, among many things, a hosted control plane. The hosted control plane allows us to treat API gateways as a single unit for scale, obviously, up and down. And what we can do is we can configure this hosted control plane, and it will manage the runtime data planes or the actual API gateways for us. Connect provides tons of other features that I'm not going to go into today, analytics, dev portals, etc. To get started, I want to use APIs because I'm a believer in APIs and automation. I'm going to create a personal access token here that will allow me to work with Connect programmatically. So I'm going to go into here and I'm going to go ahead and save that token that I just created. That allows me to use it directly on the command line, and I can do some things like use the Connect API to create one of these control planes called a runtime group currently. I'm going to give it a name called Hello World. I'm passing in my credential, and we're creating a runtime group on the fly here using an API. So we have a Hello World runtime group now. This is our control plane. And what we want to do is we want to deploy a Kong gateway into this hosted control plane, connect them together. The easiest way to do that in a development environment is just to run one locally on your machine. Since I have Docker, I'm already doing that. I'm just going to do that here. So what I'm doing here is Connect gives me these nice little helper functions to deploy a Kong gateway. And all of the secrets and all of the things you see above are used to connect the running local API gateway back up to the hosted control plane. Before I run this, though, I need to connect. I need to make sure that I run the gateway on the same network as our running service. That way they can communicate. We're using the API gateway to proxy traffic to our service. So that connection needs to be valid. So what we have now are two containers running, a Kong gateway and a Hello World service. Okay, so what we're going to do now is let's go ahead and build out the APIOps workflows. So how can we do that? Well, we're going to use GitHub Actions, if you're familiar with it. This is a command I've set up to create some necessary folders and things that we're going to work out of in order to enable APIOps and automated workflows. Creating a GitHub workflows folder, that's the well-known place that GitHub uses for its GitHub Actions. We're going to create a folder called Connect, and inside of this Connect folder, we're going to store the actionable Connect Kong declarative configuration files, and that's what's going to drive our automation. I'm using here the GitHub CLI to create a repository, make it public, and that will actually reach out to GitHub and create that new repository. So if I go up to here, you can see we have this new repository called My API. There's a couple of manual steps I've got to do here quickly to make this work. GitHub Actions needs special permissions because what we're going to use GitHub Actions for is to create PR-based workflows. When files are modified in the repository, we're going to create PRs that will then automate the driving of changes to the Connect system. And so we have to give it the proper permissions. We also need to give it a secret, which is that same secret that we created at the beginning. Connect supports service accounts and all sorts of RBAC and other security, but for the purposes of a demo, we're just going to do this here. So I'm going to copy in that same personal access token, and I'm going to use it for this well-known variable, and this will be fed into the actions, into the CI/CD system as it does things. So here we go. We actually now should have the necessary security settings. And before I go on, what I want to do now is you can ask the AI systems for help in building these GitHub Action workflows. In my experience, they're not well trained on these tools. And it's also quite difficult to express the question clearly enough to have it generate these for you. In the interest of time, I've bootstrapped this for us. So I'm just going to manually copy in some files. There's 3 GitHub Action workflow files that I'm going to show you. But what I'm going to do is I'm going to show you that within GitHub. I want to go ahead and just commit these in because we can just get the whole thing started just by doing that. So once the workflows are in the repository, they will start to be evaluated by the GitHub Action CI/CD system. So I'm adding the files, I'm doing a commit, and I'm just going to go ahead and push them up to our repository. We'll go through the files in a second. As you now come over to GitHub, you can see all of our files are up here. And if we go into Actions, we have running workflows. So we're going to go through these one at a time. The first one I created was called Convert OAS to Kong, and it lives in this file right here. What this does is it says anytime a push happens to the main branch for this particular file, and you'll recall back we asked ChatGPT to create this file for us, we're going to run this set of jobs. And this set of jobs includes checking out the repository, setting up the deck tool. So this is a little job that is provided, Kong provides, that allows us to install deck into the CI/CD workflow here. And here's the key part. We're going to use our deck APIOps style commands to convert that OpenAPI spec file into a staged declarative configuration. So here we're saying convert this file to output to this file. And I simulated one of these kind of multi-stage APIOps workflows by adding a second step, which is another APIOps command we provide called add plugins. This allows us to layer on a plugin using a JSON path selector. So here I've said for all the services in the input declarative configuration, add a rate limiting plugin with this 5-second configuration. And here we're going to output it out to this, back to the same file. So we are using the same file as kind of a working place to build up a configuration. And as I mentioned before, we're going to stage this into a PR so that it can be merged and it can be reviewed and then merged prior to further being acted upon. So that's workflow number one. If we go look at this now, we see that that action completed and we have a new pull request. And that pull request contains a new file, Kong-staged contains, and this is a Kong declarative configuration file. It has a service. That service is configured on a particular port. It's configured on a particular host. This matches what's in the Docker container. From our earlier request to ChatGPT, we said build a Docker container that can do this, build a Docker image that can do this, and run it like so. So this matches. It matched what we told Docker, and it matched what we told ChatGPT to do in the OpenAPI spec generation. We have a route that matches on /hello, and we have a plugin on our service for rate limiting with a 5-second. So this is a combination of the convert and transform stage that I showed in the diagram earlier, and it's staged into a file that we can review. Let's pretend that everyone reviews it. Everyone gives it the looks good to me. We can merge this down. And what we now end up with is the execution of a second workflow. So let's look at that second workflow. What we're doing now is we're saying, stage the Kong changes to synchronize. This is kind of like another step before production. Basically, what we're doing is we're going to use deck to determine what changes will occur in the production API gateway prior to actually pushing them up. You could skip this stage, but this allows us to do one more step of verification in case there's drift in, let's say, the production system. Let's look at that file real quick. Here's the workflow file. This says on pushes to main to that stage file that we just created in the previous step. Do some very similar things, set up deck, check out the repository. What we're going to do is copy the staged file to another file and make this act as if this is the production file. So here's kind of the working file, and here's where we want to operate off of. There are other ways to do this, of course, but this is a very easy way to do so. We're going to use a deck tool command called diff. This will connect up to our configured control plane. In this case, the Hello World runtime group that we created earlier with our configured secrets, and it will calculate a difference. This is the calculating any drift that may have occurred. So what is on the production system versus what's in this state file that we've just passed into it. We're going to use that diff to then create a PR. That PR can be further reviewed and approved or rejected. So it's like a final step before pushing into production. So if we go look at the PR that it created, this is a deck diff output pushed into the description of the PR. We can look at what files have changed, and this is the same deck file that we mentioned earlier. It's a copy of the same file. As you would go forward with this, the whole file wouldn't change. It's just because we have a net new environment here. It's basically saying nothing, an entirely new file has been given. So we can pretend that the platform team has looked at this and they all approve, and they can approve the PR and merge it down. And then finally, one more step occurs, and that's called deploy changes to Kong. And so what it does is it looks at that other file. This is the quote unquote production file. Anytime a push to this file on the main branch runs, do the exact same thing. Check out the repository, set up the deck tool. But this time we're actually going to run the sync command. The sync command is the thing that actually enables the changes. Right. So if we go look back at that action, it succeeded. So we can go in here and look at the log And we can see that the deck sync command returned a positive return code. We know it's exceeded, which means that those changes got pushed. So if we go up to connect, what are we going to see? Well, we have the hello world control plane that we created, and some things have changed. We now can go into the objects that are configured within the runtime group or the control plane. And here we see we have a new service, Hello World API. It points to the host Hello World on port 3000. It's enabled. We have a route that looks for requests on /hello. And we have a rate limiting plugin, which is configured to the service and is configured for a 5-second window. So you can see we never touched any of these screens. We enabled the deployment of this configuration using just a pure APIOps workflow, akin to a GitOps workflow, but it is a GitOps workflow. And so this control plane now should have pushed down that configuration to our API gateway. So if we go back to the terminal, we can ask the service directly because we're on the machine, hello, and get a response. But we can also proxy through the API gateway and get a response. That has been pushed through the API gateway and includes rate limiting plugin capabilities, right? So this is where the API gateway provides that value of the abstraction layer in front of the service, right? What else can Connect do for us? We'll just click through a couple of these briefly, but for example, it can give us traffic. So we can do things like run this and generate some fake traffic, and we can see analytics collecting data on our APIs, and we can look at individual requests. And this is a single pane of glass across your APIs. So you can imagine your domain-driven design teams all aggregated under this this control plane, and you could see them all together and get reporting, debug issues, this kind of thing. There's also dev portals and API products. I'm going to skip those today, but this is Connect. What else can I tell you about this? So if you'd like to reach out to us about this APIOps, I want to show you this GitHub repository here, go-APIOps under the Kong organization. This is where we're building out our APIOps capabilities for Deck. It's a library Go-based in here that you can reach out to us on, file an issue or open a discussion. That way, if you want to contribute or help us build out these capabilities, we would love that. Kong Connect provides a suite of APIs, and all of that is available to you on developer.konghq.com. I use the Connect Runtime API to automate the building of that runtime group earlier. So there's a catalog here of various things you can do, including building out dev portals, identity management on the Connect. So I mentioned service accounts, things like that, all API driven, as well as the runtime groups itself. So I wanted to share a reference of the tools that I used here today. Obviously the Deck tool, Kong Connect, ChatGPT. I was just using an account that I have, and the ChatBlade account is configured to talk to that. And of course, GitHub Actions, and the GitHub CLI. And again, I would like to go back to the front. And if you'd like to reach out to me to discuss this or any of the other topics that about Kong or APIs, API gateways, please feel free to reach out. Thanks for listening today.